and I'll stop talking and get my Q&A open.
Oh yeah, look, it's got a little record blipper
Yep.
inside the cloud.
All happening.
Good, good. Yeah. Getting a few more of our attendees rolling in now, so I should probably keep that off the screen there. I'm just going to put this up as a starter slide to allow those of you who have already arrived to start having a little go at this one here.
Cool.
Seeing if you can name as many of these energy resources as you can.
We'll probably get people joining for the next, I would say, 5 minutes or so.
Yeah, I'm going to wait
Yeah.
about that time anyway. But yeah, I'll be back in 1 second, John.
Okay. Yep. Hello, everybody. I'm sure that you heard myself and Mr. Brown having a conversation there. We'll obviously wait till everyone else has joined just after 1 o'clock. If you want to ask any questions, same as before, you can use the Q&A box. So down the bottom, there's a little symbol Q&A. If you type it in there, that pops up for me, not for Mr. Brown. The hands up button doesn't do anything useful in this webinar. It's for a different function. And I will stop talking now and leave Mr. Brown to get on with it in a second.
Hello, hello. So we're just waiting for a few more people to arrive in order for us to begin. And as they know, the session actually starts at 1 o'clock. So we've got a few minutes before that time starts anyway. But if you have just arrived, I think you might have heard this already, for those of you who are here. But I'd like you to just look through the silent starter that's being projected to you at the moment. And see if you can name as many of the energy resources from these pictures that you can. So what might you call the type of energy resource seen in the top left-hand corner, or the one just below it? And there's a challenge question for you there, which will link onto one of our success criteria later in this presentation. The challenge question is, can you group them and define each group? So how might you group some of these different energy resources? There's two main types that we might refer to. So just a couple of minutes, well, a few minutes until we start, as I said. You've still got time to go to the toilet quickly if you like. See if I can. Got a few more rolling now. As I said to you before, guys, we've got a starter on the board. Well, not on the board, being projected, sent through the internet to your homes. And the starter is, as you can see here, it's being projected to you now. So it lists or shows a load of pictures of different energy resources. I'd like you to name as many of those energy resources as you can. There's actually 9 main ones which you should be able to identify. So there's a few that you would be very aware of. You've seen lots and lots of times, used lots of times before, perhaps.
Hello, sir. Can I interrupt you for 1 second? Before you start, I just remind everyone here that Mr. Brown is doing Year 9 Foundation, and that if you were expecting to do higher tier, you need to be in a different webinar. And to find that, I sent you the whole of Year 9 an email 5 minutes ago with a link to higher and foundation. So if you're here and you think you should actually be in a higher webinar, then you need to come out, find that email and click on higher, and that will be starting about the same time. So in just a moment. Sorry, sir.
No, that's great. And obviously, just as a quick note, some of you might be joining us via the YouTube links, which are sent after the lesson. So just to remind you that for any of the polling questions which I send out, I'm going to be reading these out as I go through them, and I will list off some of the answers, the possible answers, and then you can sort of just play along as you're watching through the PowerPoint. So I'm going to start in a moment's time, just waiting for a couple more to arrive, but this it's not too essential. As I said, there might be a few of you joining us after the fact. So this starter, as I was explaining before, is based on the energy resources, and that's what we're going to be looking at today. We're going to be looking at national and global energy resources, and we're going to talk about some of the different energy stores that they might have within them, and some of the energy transfers which are taking place, moving from one store to another. Okay, and we're going to be using that kind of terminology as we go through this lesson as well today, making sure that we're using the correct keywords, and also making sure that we're not using a few phrases which students often use and it loses them the marks. So we're making sure that we're using the right language in this lesson here today as well. So just going to briefly show you the success criteria for today. I will go back to that original slide. So in our success criteria, we're going to be looking to, as I said, identify some of those energy resources and the stores of energy that are within them. We're going to be describing some energy transfers from the energy resources, so using those as examples. And we're going to describe what renewable means in terms of the different types of energy resource. Then finally, we're going to touch on how to compare using different sources of information like graphs or data. We're going to compare how energy resources are used and explain some of the patterns and the trends in how people use them or how different countries are using them. And there's been a couple of different incentives that have been released in Britain about that actually recently. So I'm just going to mention those later. So the second target actually does relate to the challenge question here. And I'm going to go through some of these energy resources with you now. So, so obviously in the top left, we've got ourselves some solar energy. And just below that, we've got one of the fossil fuels, which is coal. We've got some more fossil fuels at the bottom there with propane gas. And right next to that, we've got a sort of petrol refill station, and that's out in the fields because it's actually indicating biofuels. So we're going to talk a little bit more about biofuels later, not in too much great detail, but just to explain that obviously biofuels slightly, well, they are different from fossil fuels in the fact that they are grown to make a fuel, whereas fossil fuels exist as fossils in the ground before they're old remains of living organisms, millions of years old, that have to form in that very, very long process, hence them being non-renewable. So we've gone through a few of those there. We've got nuclear in the middle. I'm going to use my cursor to sort of point out some of these. So this is the nuclear here. We've got the wind energy, and we've got crude oil, which is obviously another fossil fuel, should be down in this corner here with these guys. And we've got geothermal here. This is very exciting stuff. Iceland uses lots of this, being a volcanic island. They've got plenty of geothermal energy available to them there. We've got tidal energy in here. You can see the very large turbines underneath, which my bar is blocking up at the moment. And we've got hydroelectric energy up here as well. There are 9 in total, and I'm going to run through those as we move through our lesson, and especially when we get into the second target here, because you guys are going to be filling out some of the remaining energy transfer diagrams for those different energy resources. So let's just bring it back to what we learned in our webinar last week, where we were talking about the law of conservation of energy. So energy resources, people often get confused with this, saying that, well, if energy can't be created or destroyed, how come we've got energy resources which give us lots of energy? Now, it's really important to remember that all of the energy resources that we are using, whether it be wind, whether it be solar, whether it be the fuels, the crude oils, they already have a store of energy, which they may have got from somewhere else. It's been transferred from a different store elsewhere, but they all start with a store of energy, which is going to be transferred into a more useful form of energy, hence why we use them as an energy resource. So here's my picture from last week, where I showed you some of the different stores of energy. And we've got the elastic potential, the magnetic, the electrostatic, thermal energy, gravitational potential, chemical, kinetic, and there's also one not shown by this lovely picture, which is the nuclear store of energy as well. So we've got all of these different stores of energy. And as I said, it's really important to remember that all of those resources, those energy resources, where we generate our electricity from, where we transfer the energy stores from, all of those have got a store of energy, and it will be different for each one. We're going to look at that as we move through this lesson today. So actually, I want to, just before we move on, and after I've spoken about those stores of energy, I just want to quickly double check with you in a polling question whether or not you can identify which of these is not an energy resource. So I'm going to give you one of these polls very quickly, just to sort of start us off here. So we've got, this is the poll from last week. Let's quickly get the other one. So I would like you all, if you have access to a computer and you can see this poll arrive on your screen right now, I'd like you just to have a quick go and answer which of these you think is the correct answer. So in fact, I'll just read the question for you because it makes more sense. Which of these is not an energy resource? Coal, geothermal, wave, or elastic potential? And you see I'm hiding the poll this week because I noticed last week that you could see what the most common answers might be. So I'm just going to read that one last time for you, for anyone who's joining in later, might not be able to see. Which of these is not an energy resource? Coal, geothermal, wave, or elastic potential? So last time, which of these is not an energy resource? Is it A, coal, B, geothermal, C, wave, or D, elastic potential? Let's have a quick look, see how you guys are getting on. Okay, good. Yeah, really, really good. So the majority of us obviously went for the elastic potential there, which is the correct answer. Fantastic stuff. A couple of us get mixed up with coal and geothermal. As I was saying before, coal is an energy resource. We use that to generate electricity in some cases, or even just to keep our homes warm. Geothermal is also another energy resource coming from volcanoes or drilling deep within to get to an area where you can tap into the geothermal activity under the crust and heat up some water again, transferring that energy again to turbine and to turn a turbine, and then to generate electrostatic energy, which is transferred to your homes. Wave energy is also another form of energy that we use, renewable energy resource there, and then elastic potential is a store of energy. So elastic potential is the correct one there. Okay, so let me get back to my stores of energy here. Each of our energy resources has a store of energy to begin with, just like these on the board. Now, you might be asking yourselves, or you might already know the answer to this question, why do we actually need energy resources? And I've given you a couple of ideas about coal just before. Here are the three main reasons why we need energy resources. So we need it for transport, to transfer the energy from petrol, diesel, whatever mode of transport you're going in, some sort of fuel has a chemical store of energy. It's transferring into an electrostatic store and then into a kinetic store to push you and drive you forward. So we've got energy transfer going on there. We've got second reason, generating electricity for other use. So this is in homes, in industry, any device which requires an electrical current, we would need to generate that electrostatic energy from another store, from an energy resource. Okay, so you obviously know that we use a variety of wind turbines on Brighton seafront, and some of that electrostatic energy would be transferred through the wires into your homes, into the industry, and then you'd use that to charge your phones or put a TV on or anything else which requires electrostatic energy. Finally, heating. Some of you might have electric fires, which would go through the same process that I had before, I just explained before. Coming from a power station, from a wind turbine, any other energy resource, and being transferred into your homes. However, in homes, you might go directly to the energy resource, and you might have a coal fire, for example. And that coal fire would be transferring the energy in your home from a chemical store straight into thermal. Okay, so we're getting some energy transfers there. And as I'm saying here, all of these are energy transfers. They all require energy to be transferred from one store to a more useful store that we can use. Right, so if we were writing out energy transfers, we might write them in like this. So we might have our energy store on the left, and then the energy store on the left, and then the energy store which is being transferred into on the right. Okay, they can be a little bit more complicated than this. We're going to see one in a moment. And I'm really dotting around in the polls today because I've literally just realized that I haven't done my second poll. So very, very sorry about this. But I'm actually going to do a very quick... No, I'm not. No, it's after this one. I'm really confusing myself. So we've got our wind energy here. Here's one of our energy resources. And as I said, we have the energy store on the left, and then we're showing what it's being transferred into on this energy store on the right. So we start off with wind particles, and we know that wind blows against us. That's moving energy. So we've got a store of kinetic energy in the wind. That's going to turn the turbine, and they're going to be moving around. We see that all the time on the seafront. They've been put offshore so that they can obtain more moving kinetic energy from the wind. and that kinetic energy is going to be transferred into an electrostatic store when it's pushed the turbines round. So they help through the motor effect to generate some electrostatic energy, and then that can be transferred into your homes. Now, for each of these energy resources, we're going to look to see what the energy store is. We're going to discuss whether or not it's renewable energy, and whether or not it's reliable, and whether or not it's used in the UK. So these three words, renewable, well, the two words even, renewable and reliable, these are really, really important key words when we're talking about energy resources. In an exam question, they could ask you whether or not this energy resource is renewable, and they could also ask you to determine whether or not it's reliable. So let's start off with renewable first. Now, in renewable energy, we are talking about stores of energy, or sorry, energy resources, which can be replenished very easily. Okay, so in wind energy, we're not going to really be using up that wind energy. We're going to be transferring the kinetic energy into electrostatic, but we're not going to stop the wind from existing by harnessing its energy. Okay, it is easily replenished by the wind on Earth. Is it reliable though? So in England, it's perhaps more reliable than in other countries because it's quite windy here. However, it's not always windy. So it's not 100% reliable. It's not very reliable wind energy. Because say, for example, it's a very hot, still day, and there are lots of people who have got their electric fans on. So they're using up, well, not using up, I should use the correct terminology. They are transferring that electrostatic energy in the national grid into their electric fan, which is transferring that electrostatic energy into kinetic energy. It's basically doing the opposite of what the wind turbine is doing. So transferring the electrostatic to kinetic, and it's pushing air around your room, keeping you cool. Now, the only problem is, if everyone in Britain had their fans on, then there would be a serious lack of electrostatic energy in our national grid. And if it's not windy outside to keep you cool, it's not going to be windy pushing the wind turbines around. So even though there's a demand for lots of electricity, there's not enough electricity being produced. So it's unreliable. It's not always windy, okay? And you can't turn the wind on when you want. So when we need lots of electricity, we can't just tell it to start being windy. Unreliable, okay? So in these slides, I'm going to show you a model of what you guys are going to create at the end, because you're going to have to fill out some slides like this. So I'm going to put a tick for it being renewable. I'm going to put a cross for it being reliable. And we can all see out on the seafront, if we had a stroll down to the beach, we'd see that these are clearly used in the UK. Now, I'm going to go on and show you a couple more of these, and we're going to talk about renewable, reliable, and used in the UK again. Now, this example, the nuclear energy, we've got the energy store being nuclear. Now, in a nuclear power plant, that nuclear energy is going to be transferred into thermal. That thermal energy would then go on in a chain reaction to provide steam, to push a turbine round, just like with the wind turbines, but steam's pushing it this time. And that would transfer into electrostatic as well. So I've got an example of that in this next slide for the coal station, power stations. So talking about renewable energies. Now, nuclear energy is one which often confuses people. They think of it as being a bad thing because they've heard lots about nuclear power stations breaking down, and they've heard lots about nuclear effects on mutations of organisms and things like that. Now, nuclear energy, when it's done correctly, is a really, really efficient, well, not really efficient, but a really useful process, because it allows us to produce it allows us to transfer nuclear energy into electrostatic energy, which is really, really useful. And it doesn't produce greenhouse gases, because it does produce steam in the heating, but it doesn't produce greenhouse gases. So it's not going to be producing lots of polluting gases. It does, however, produce toxic waste. So that's quite hard to store and get rid of. But in the long term, to help us fight global warming, it's quite a good interim model to use. It's quite a good thing to use in between moving from fossil fuels to purely renewable energy. So renewable, it is not renewable. You have to, you can't replenish your stores of nuclear molecules, of nuclear substances. You would have to go off-world probably and find more of these radioactive substances. Is it reliable? So it takes a while to set up, but in the same example of sitting in a hot day with the fan, I can up the amount of nuclear energy that is being transferred. I can do that at will. So it's not determined by the weather, it's determined by us. Therefore, it is reliable. So it's not renewable, it is reliable. And some people don't know this, or they often think that we don't do it here, but it is used in the UK. In fact, there's a nuclear power plant not even that far away from us down in Dungeness in Kent. And that will be operational until 2024. So there are various other sites around the UK, well managed, maintained, and obviously they're coming up to the end of their life cycle, so they're being reassessed to see if we are going to continue using nuclear fuel. So we've talked about the energy stores there again, starting with nuclear, transferring to thermal. If I really felt adventurous, I could move this on further and I can show you more energy transfers. So this is a good example here for coal energy. It's a similar sort of idea. For the nuclear power station, the starting store of energy would be nuclear, as it shows in here. But otherwise, they'd be exactly the same in the full transfers that would be occurring. So for coal energy, we've started with the chemical, we started with coal, and we are heating it, transferring the energy from chemical to thermal energy. Again, this thermal energy is going to be heating some water in here, which turns into steam as it gets hotter and hotter, and it starts to boil through the pipe here, which is going to be turning some turbines again. So we love the use of turbines in generating electrostatic energy. There's pretty much always a turbine involved, okay? Whether or not it's steam that's pushing it, whether or not it's wind, or whether or not it's water pushing through a hydroelectric dam. So we've gone from chemical in the coal to thermal in the steam, and it's transferred to kinetic energy in the moving turbines. And finally, those moving turbines, through the motor effect, help to transfer to electrostatic energy in the wires, which then we can use in our homes, or in industries, or in markets, or wherever. So let's go to these three questions again. Is it renewable? Is it reliable? And is it used in the UK? So coal energy, the fossil fuel, comes from the ground. Anything which has the name fossil in it comes from the ground, okay? Fossil fuels, just general fossils, they all come from the ground. So these fossil fuels, the coal, which is formed from old trees that haven't properly decayed, they've taken millions of years, hence them being called fossils from the ground. Are they renewable? Can I easily replenish that store of coal? Not really, no. It's not renewable. It'd take ages for that for us to replenish those stores. Is it reliable? Can I just burn coal when I want? Assuming we've got enough coal, yes, I can. So it's reliable. If there's not enough electricity in the UK, they will burn more coal in order to keep up with the demand of electrostatic energy. So it's reliable. We can turn it on and off when we want, generate the electricity when we want. Is it used in the UK? Of course it is, yeah. It's used, it's been used for the last 100, 200 years, coal energy, even longer, sorry. Right, so as you can see here, I've got the energy store and the transfers which it goes through to transfer into a more useful energy store. Now, I've got the remaining 6 slides, which I'm expecting you guys to fill out, and I've given you some hints and clues in here as to some of the transfers that take place along the way. It's important to, if you need to look up what each of these energy resources are, you can do that in your own time. And also, if you can add a picture to help show it, that would also be good. For example, for the hydroelectric energy, it's really useful if you find yourselves a picture, because it will help you to remember what hydroelectric energy is in the future as well. Okay, so I want you to go through for each of these and to type in the store that it starts with, one of the stores that it's transferred into, and then its end store. And you also need to answer, putting a tick or a yes or a no if it is renewable, and a cross or a no if it's not reliable, for example, either. So you can answer these questions: is it renewable, reliable, and is it used in the UK? Put a picture in, and then name the energy stores in there as well. So this brings me on to my second poll, which I nearly jumped the gun with before. So let's set our second poll on here. Second poll. Okay, right, quickly, let's get rid of the poll thing again as well. Otherwise people cheat. So poll 2 is, which energy resource starts with gravitational potential energy? Is it A, a hydroelectric dam? Is it B, solar energy? Is it C, coal? Or is it D, nuclear energy? You might need to use your process of elimination for this one, guys. I haven't given you the answer so far, but if you think about what we've talked about already, the types of energy stores and the energy resources and the stores which they have, which energy resource starts with gravitational potential energy? Is it A, the hydroelectric dam? Is it B, solar? Is it C, coal? Or is it D, nuclear? Quick look. Oh, nice one. Thank you, Mr. Lamb, for checking our Q&As as well.
Yeah, I'm just going to remind people here that I haven't had any questions for a little bit, but if you if you missed something Sir says, or you're not sure about something, if you type something in the Q&A box, I can type an answer back to you.
Thank you, sir. Can you see me on the video? Because I did enable it, but I can't see myself.
Yep, I can see you absolutely fine.
Cool. Oh, yep. Okay, cool. Better not pick my nose then. Okay, so we've had a couple of minutes on the poll there. I am going to have a quick look and see how we're getting on. Don't want to hold you guys for like ages and ages today, because I've given you a few questions to go over, and I want to talk about that before the end of the video as well. So 100%, guys, nailed it. Really happy with that. So 100% of you have said that hydroelectric energy resource is the one which starts with the gravitational potential energy, and you're all 100% correct. So obviously, at the top of a hydroelectric dam, you've got a load of water, and that water has a store of gravitational potential energy because it's higher up, and in the process of it falling, goes through a turbine. Told you we love turbines to generate electrostatic energy, and as it falls through the turbine, it turns, transferring that gravitational potential energy to kinetic energy, which is transferring into the turbine, turning it with kinetic energy, and then it's transferring to the electrostatic store there as well. So fantastic work there, guys. Really happy with that. And as I said, there's the rest of these energy resources which you need to be able to go through. And just a quick reminder what the energy resources are. We've got wind, we've got nuclear, we've got coal, we've got biofuel. I said I was going to mention this before. Biofuel is a process used where we grow plants or plant materials like sugar cane, for example, in order to distill it and turn it into more useful fuels. So it's a way of trying to make your fuel carbon neutral, because the plants are absorbing as much carbon dioxide as they will then release when they're burned. Okay, so that's what biofuel is. Hydroelectric is the dams, as we saw. Geothermal is the volcanic energy that they're using, hence why Iceland uses it, because they're a volcanic island. Tidal energy, solar energy, using the solar panels, wave energy, which are great, but they do take up a bit of beach space. So there's a few sort of advantages and disadvantages for each of these. And one of the main topics of the advantages and disadvantages is whether or not it's renewable or non-renewable energy. And as I said before, with the nuclear, it's really important that you don't get renewable and non-renewable mixed up with being good for the environment or bad for the environment. Because as I said, nuclear energy falls somewhere in the middle there, not producing greenhouse gases, but producing toxic waste instead. Okay, so, and not being renewable, so it's non-renewable, the nuclear energy there, but it's still not producing greenhouse gases. Right, so the definitions are just here, and it's really important that you guys get an idea as to what renewable energy is and some examples of them as well. So it says, obviously, a renewable energy resource is one that is being or can be replenished as it is used. For example, solar, wind, etc. All of those are renewable energy resources because they're continuously replenished. Okay, and it's talking about within a reasonable lifetime of a human as well. Okay, so as I said to you before, you could replenish the coal stores. So you could make a little store of old trees, compress them underground over millions of years, and you would form some coal there. Okay, but am I going to be able to use that coal in my lifetime? No. Are my children? No. Grandchildren? No. Okay, so it's not within any sort of feasible lifetime that you would be able to replenish coal or any of the fossil fuels. Hence why they are a non-renewable energy resource. So a non-renewable energy resource is one which cannot be replenished easily. For example, all fossil fuels, coal and petrol, etc. And then the other one is nuclear. Okay, so that's a non-renewable energy resource. It's a finite resource, meaning that it's there's a limited amount of it. So, got the definition for renewable and non-renewable energy resources, right? In one of your tasks later, you are asked to complete this table, which has all of the energy resources. You can see them on there, all 9. And you need to state whether or not they are renewable or non-renewable. And I've given you a hint there with the fossil fuels bit being in there. So I'm going to come back to this bit, and we're just going to do another poll just to assess. Oh, I haven't ended the last one. Nice reminder of the 100% there. And so we're going to do poll 7. Launch poll, simple, true or false. Okay, and I'm going to squeeze this one on. Okay, so that you can't check that bit out. Right, so question is, I've shown you the thing there as well, haven't I? Are fossil fuels, wait, let me retry that. All fossil fuels are non-renewable. Is that true or false? All fossil fuels are non-renewable. Six voted already. Loving it, guys. Just got a few left to get the votes in on our one here today. Can I just say to those of you who are here, it's not only really, really good work on your behalf there, but it's just really, really nice to see that a few of you are logging in. It definitely makes my job a little bit easier knowing that I've got a few of you guys coming along and joining in with the webinars live. So yeah, thank you for doing that, and keep coming because I'll be going for the next well, until the end of term. So one more vote in. Ah, and he's in. They're in, nice. Okay, cool. So it's divided you a little bit more. Now the wording on this might have confused you a little bit. So I've said all fossil fuels are non-renewable, and the majority of you have got it correct there. So that is true. Fossil fuels are non-renewable purely because of the fact that, as it says in our definitions up here, let's go back up here, all of those energy resources, all the fossil fuels, are not easily replenished. Okay, as I said to you before, coal take millions of years, petrol millions of years to form, shale gas millions of years. They are all not easily replenished. Unlike biofuel, which, as I said to you before, just grow some more trees. Obviously, it still takes a little bit of time, but you can do that feasibly within our lifetime. Yeah. So this brings us on to our final success criteria. Now, it's really important to identify that when we're talking about energy resources and when we're talking about graphs that show their use and things, that you take the time to just read through the information you've got in front of you. And I've given you a couple of different forms of graphs that we've got here. Okay, so we've got a pie chart and we've got a bar graph in a sort of fashion. Now, both of these are probably, the first one, the pie chart, is similar to one that you would probably get in a question. This is one that's taken from one of our AQA textbooks. And as you can see, it's fairly neat, and it's not overloading you with information. The second graph is not one that you would likely get in an exam at all. As you can see, I've taken this from a website online. And this graph, even though it's fairly heavy with information, I think it's still really important for us to be able to look at something like this and be able to make our own judgments and to assess what information is being given to us there. So for the first one again, we're going to be looking and comparing how energy resources are used and explaining any patterns and trends in their use. So what I mean by that is, out of the different energy resources that we can see listed here, these are some of the main ones which you've just spoken about, how has their use changed over time? Okay, the next graph is better for that aspect. Okay, so on here, as you can see, we've got so on the bottom it says world energy demand and sources of energy in 2013. So this is about 7 years old now in terms of the sources of our different types of energy. In the second graph, it says energy sources for electricity. Okay, so it's showing you, in fact, how the amount of coal is entirely being used for electricity in here. We're not using it for steam engines or anything else anymore. Okay. Hydroelectric electricity is fairly in demand, not being used for generating electricity as much though. Other fuels, renewables, we've got nuclear in here, which is actually a different color from the first graph, a bit confusing. So nuclear is 4% in our left graph, whereas it's 16% in the generation of electricity. So as I said to you earlier in our presentation, we use energy resources for transport, for heating, and for electricity, right? Now, in a question, they could ask you how much of the coal is being used for transport. Now, in this answer, you would be thinking, okay, there's 31% of the world demand sources of energy being coal. We've also got that 31% of our source of electricity come from coal. Okay, so we can assume that perhaps they've used the same amount. Although, yeah, I'm going to go on to my next graph, because in this graph, it's going to allow you to make a more sort of comparative statement between different countries and their uses of energy consumption for transport. Now, this one again is in 2012, so it's about 8 years old, but that's not the important thing. The important factors are stated by the colors here and the percentage of world total and the different countries. So what we're looking at here is we're looking at the annual global transportation energy consumption, so the amount of energy they use for transport. Okay, So along the bottom, it shows you that this line here would be 0, 20%, 40%, 60%, 80%, 100%. And then it also shows you the percentage of world total that each country is. Okay, now, I'm going to give you just a minute to have a look at this. I want you to be thinking about on-road passengers. So these are people which are driving themselves to and from places. On-road freight, that's lorries, for example, which are transporting goods. Marine, so this could be, well, this is boats and things like that. Air being planes, and obviously rail being trains. So it shows you how much of each of these countries, how much percentage they transport energy consumption is for cars or is for lorries. How much of their percentage is consumption is used in boats? How much of it is used in planes or trains? Right. So a bit of a tricky poll question for you here. And this again is just have a look at how you guys would interpret a graph. So I'm going to give you one last poll. Okay. And then I'm going to explain the work that you've got to complete. So the last poll, launch poll. According to the graph, which of these countries has the highest number of on-road passengers? Is it A, the United States of America, B, Russia, C, China, or D, Mexico, Chile? Which has the highest number of on-road passengers? Now, this is a tricky bit. It's the highest number of on-road passengers, so it's not just percentages. Good stuff, getting your work in there, guys. And as I said, I'm probably going to take another 3 or 4 minutes to go over the rest of the work that you will be set for the rest of this week. And then we can finish. I can take any final questions if you have any final questions after I've explained this last bit. 7 voted. I'll give you another 10 seconds, guys. Sorry to rush you, but I just want to finish soonish. So, last one. Read it again. Which of these countries has the highest number of on-road passengers? Is it USA? Is it Russia? Is it China? Is it Mexico, Chile? Right. Okay. So, yeah. Okay. Now, this is what I was expecting as well. And I'm glad that it kind of got this split. So, Mexico, Chile. Most of you have chosen that because the line here is ever so slightly in front of the United States. That is really good that you're looking at the graph, you're looking at the number of on-road passengers, and you're choosing them. Okay, that's really good. However, it is USA who has got more people traveling on-road passengers. And the reason for that is because it's also really important to look at the total percentage of the world that it is. Obviously, USA has got a massive population, over 200 million. So they're 25% of the world total, whereas Mexico, Chile, only 3%. So even though they've got a larger percentage of on-road passengers, the number of people, the number of on-road passengers will actually be higher in the United States. Okay, but otherwise, really, really good. You've read the graph, you've looked at the bars, you've identified that these are the on-road passengers and that this line is further than the USA one. That's really, really good, a really important skill to be able to analyze a graph like that. However, it's also important to remember that if I'm asking for the highest number, then it will be USA because they've got a larger world total. That was a really tricky question to end on, guys. Don't feel disheartened if you haven't got that one correct, because I kind of deliberately put that in to be able to talk about it, okay? So, and actually most of you have done what I asked you to do and read the graph properly, so that's really, really good. Okay, so I'm just going to end that there for the poll. And as I said, I'm going to just talk to you about the remaining tasks. I'm aware of the fact that for the compare how energy resources are used and explain patterns and trends in use, we've really zipped through that at the very end. But the important factor from these last remaining 2 slides is that you're able to look at how energy is being used and to refer to perhaps the reliability of some of these energy resources and why they're used for certain things. Okay, so for example, the amount of oil used for generating electricity from the first graph to the second graph is obviously much, much lower, because if we can, we need to be doing it through means which don't produce pollution, like nuclear, which doesn't produce any of those greenhouse gases, or other renewables, like these 5% that we've got here. Okay, so, right. In the last couple of slides, I've got a list of some of the advantages of non-renewable energy resources and some of the disadvantages. So we've got a few things in here which you guys might be able to come up with. Really, really importantly, where it says here, one of the disadvantages, pollution, if you just state in a question, disadvantage of using coal is that it causes pollution, you would not get a mark. You have to state what the pollution is. So you have to say, for example, coal releases pollution such as carbon dioxide, which leads to global warming. Okay, that is a really good answer. State the gas, state carbon dioxide. If you can't remember any others for any of the fossil fuels, just state carbon dioxide, because more often than not, you'll get a mark for that. If you state it pollutes, pollution does not give you a mark. Okay, you've got to state the greenhouse gas which is causing that pollution. Okay, be specific. The second one here, we've got a list of advantages and disadvantages for renewable energy resources. We've got some lovely pictures around here as well, showing all of these different renewable energy resources. Now, you are going to have to use those when you answer this question here, question 6, which is to compare the use of wind energy to coal energy, and there's 4 marks available for that. So these are the tasks for you to do now, or before the end of week when your hand-in date is due. Firstly, complete these tasks. You need to complete the table on slide 22. Go down one, that's the table. On slides 10 to 15, you need to finish those energy transfers and put a tick or cross in the question boxes. So those are these ones that I'm talking about. So you need to finish these off for the ones that don't have, the ones that are missing things, you need to finish these off. Then you need to complete the table on slide 23. That's this one. And then finally answer these questions. So you need to identify 3 renewable energy resources. Why are fossil fuels non-renewable? And compare the use of wind energy to coal energy. There's 4 marks available for that last question. Okay, so there's a few things for you guys to get on with there. And if you've got any questions about any of those tasks now, then I'm more than happy to answer them for you. But if not, then we're going to finish our presentation there. So again, thank you very, very much for watching our session there today, guys. And make sure that you get your work done for your teacher, handing those in on your Google Classrooms with enough time for them to be able to go through and give you any feedback where they can. Hello, sir.
Hi, sir. Thank you very much. I'm just going to remind people again, if you've got any questions about that, if you type them in the Q&A box now, I can read those out to Mr. Brown or try and answer myself. I can see someone's putting their hand up. I'm afraid that doesn't work in this one. We're not able to click on it and take your question. So you need to type it in the Q&A box if you've got a question. Otherwise, you're obviously free to leave now. Thank you very much for attending.
Thank you very much, guys. Have you got any questions there from them, sir?
No, I've just got someone said, oops, for putting their hand up. We've got 6 people left. So
Okay, cool.
Are you able to stop the recording, sir?
Yeah, that's fine. I'll just stop the, hold on. Oh, I think I just stopped the share. Let me just stop.